Hey guys, our objective for today is to decide whether x minus k is a factor of a polynomial using the factor theorem. So we'll look at example number 1. Example number 1 says to determine whether x minus 1 is a factor of each polynomial. So example number 1, we have this polynomial here, f of x is equal to 2 times x to the fourth plus 3x squared minus 5x plus 7. And we want to decide if x minus 1 is a factor of this polynomial here. So the solution is, by the factor theorem, x minus 1 will be a factor if f of 1 is equal to 0. So we want to use the synthetic division and remainder theorem to decide. Now, when we look at the synthetic division, we see that our remainder is 7. So since the remainder is 7 and it's not 0, x minus 1 is not a factor of this polynomial. We could have also taken 1 and plug it into the polynomial, replace x with 1. 2 times 1 to the fourth plus 3 times 1 squared minus 5 times 1 plus 7. And when you evaluated that polynomial at 1, you would have seen that you would have gotten 7. So that could have told you also, that's another way to decide if x minus 1 is a factor also. Now let's look at example number 2. Example number 2 says, well, if I have this function here, right, I want to know if x minus 1 is a factor of this function. Well, once using my synthetic division, I see that the remainder is 0. The remainder is 0. Since the remainder is 0, I know that x minus 1 is a factor. The solution, because the remainder is 0, x minus 1 is a factor. Additionally, we can determine from the coefficients in the bottom row that the other factor is 3x to the fourth plus x cubed plus 2x squared minus 6x minus 1. This is the bottom row. This is where we're getting this from here. This and this means the same thing. We're just attaching the variables and their exponents to the coefficient. So we can write it in this form. This is the form we can write it here. You see x minus 1 is a factor, and the other factor is this polynomial here. In a later video, we will find out how we could find the other factors, okay?